Hey there, Chem Squad. Today we're going to learn how to use a solubility table. For some of you, you may have been taught how to use a solubility table in grade 11. For others, you may not have been taught that, so this is the first time you're going to see it. Either way, you're going to need your periodic table package, and you're going to need to find this particular handout. Okay, it's called a solubility table of common compounds in water. So as we're going through the table here, I'll show you some of the tips and tricks that are associated with this table. But first, we'll look at 4 different types of ions, and basically the whole point of this is to figure out whether or not a precipitate forms. So if you remember what a precipitate is, it's a solid substance that forms when 2 solutions or ions combine. So in this case here, let's start with the very first set. We have Ag+, okay, which is silver, and Cl-, which is chlorine. So if we were to add silver ions with chlorine ions, the type of substance that's going to form is obviously AgCl, okay, or silver chloride. But what is the state that it's in? Is it aqueous, or is it a precipitate? And we're going to abbreviate precipitate by using PPT. And just so you know, again, precipitates are always solid substances. And of course, aqueous is dissolved substance. Okay, and the symbol that we use is AQ. So we have to figure out what that is. So in order for us to do that, we need to go to our solubility table. So on this solubility table, you will notice that all of your negative ions are first. Okay, they're listed first because we always look at them first, and then we look at the positive ions. Okay, so if we go and we look at our chlorine and find out where chlorine is, okay, chlorine is right here. Okay, so Cl-. When we look at the second column to see what the positive ions are, we notice that you have silver as being on this top row. Okay, so that means chlorine and silver will be low soluble or insoluble when they're paired together, meaning they're going to form a precipitate. Okay, so chlorine along with silver, or any of the other 4 that are listed here, will all form precipitates. If you have another substance that's not any of the 5 that's listed up here, they're going to be soluble. So in our case, because chlorine and silver are low soluble, the state that it's in is going to be solid. So this will be a precipitate. Okay. So the combination of Ag+ and Cl- will form silver chloride as a solid precipitate. So let's move on to the next one. We notice again that we have chlorine, but this time it's being paired up with magnesium. So writing out the formula, it's going to be Mg, but because there's a 2+ charge, we're going to need 2 chlorines. So it'll be MgCl2. So that means we're going to have to balance out the reactant side by putting a coefficient 2. But again, we want to know what the state is. Is it going to be aqueous, or is it going to be a precipitate? So when we go back to this one here, okay, chlorine and magnesium, okay, magnesium doesn't fit in with any of the 5 that are shown at the top. So magnesium is under all others. And because it's under all others, the combination between chlorine and magnesium will be soluble. So if that's true, then magnesium and chlorine will be aqueous, okay? Meaning that this substance is dissolvable. Okay, and it does not form a precipitate. Okay. Now let's go and look at another set of ions here. Let's look at Na and carbonate. So again, we're going to go back to our solubility table. Okay. I'll choose a different highlighter color here. Because carbonate is the anion that we're looking for, we're going to scroll down until we find carbonate. And carbonate is right here. Okay, CO3 2 negative. The positive ion is sodium. Okay, so we look to see if sodium is anywhere written out here. Now, sodium, as you can see, isn't actually listed here. However, there's something called alkali ions. Okay? Alkali ions are all listed once at the top here. Okay? So if you look at the alkali ions list, you'll find that sodium is actually one of the alkali ions. All the alkali ions are ions from the first family. Okay? So technically speaking, carbonate and sodium are soluble. So that means they dissolve. So when we write out the formula, okay, CO2 has a 2 negative charge, sodium has a +1 charge. So we're going to need 2 sodiums. So we'll fix up the balancing over here, and we'll add in the CO3. And because it's soluble, the symbol that we're going to use is AQ. So anytime where you see that a substance is soluble, you basically use AQ as the state, because it means that it's dissolvable. And dissolvable and soluble mean the same thing. Okay, so let's do the last one. The last one is PO4 3 negative. So this is the phosphate ion with a lead ion. So again, we'll go back to our sheet here. Okay, phosphate is in the same grouping as carbonate. Okay, so it doesn't matter where you have phosphate, carbonate, or sulfite. They all have the same solubility rules. So all we have to do now is look for lead. Lead is not an alkali ion, right? Because lead is a transition metal. It's not from family 1. Lead is not hydrogen, and lead is not ammonium. So lead falls under all others. And the combination of lead and phosphate is low soluble. So that means it will form precipitate. So let's get the formula correct. Okay, so we're going to have PB3 bracket PO4 2. So this goes back to a trick that you guys learned in grade 10, where you basically cross the charges so that you basically get 3 positive charges, okay, and 2 negative 3 charges. So the combined charge in this case will neutralize each other to give you the formula PB3 bracket PO4 bracket 2. The substance we said was low soluble, so it will form a solid precipitate. Okay, so low soluble or insoluble always gives you a solid precipitate in the end. Okay, So figuring out whether they dissolve or form a solid is actually fairly easy and straightforward, as long as you have the solubility table in front of you. Now, there's a couple of things that I will mention about the solubility table here, so that you don't forget. When it says essentially all, okay, so you'll see them in a few places here, okay. What it means is any negative ion can form compounds with alkali ions. Okay, so if any negative ion plus an alkali ion, okay, they will always give you soluble. Any negative ion with hydrogens are also soluble, right? So that's kind of how we read this essentially all. So for nitrate here, nitrate can form basically soluble substances with any positive ion. Okay, so that's what essentially all means. It means virtually any positive ion or virtually any negative ions would have these kinds of effects when they're paired up with, alkali ions or nitrite ions. Okay, so it's important to pay attention to these lists because they are usually there to help you. And sometimes if you don't pay attention to them, okay, you'll misidentify the solubility. So for the most part, okay, the table itself isn't hard. You just have to make sure that you are looking at the right substances and that you are looking at the correct outcomes, okay, when you match them up. So hopefully this lesson here has been somewhat helpful for you kids in figuring out what is soluble and what is not. Okay, so again, soluble means dissolvable. You're going to form aqueous solutions every single time you see this word soluble. And low soluble and insoluble means that you're going to form a precipitate, okay, which is solid. All right, that's all I have. See you guys next time.